So here we have another of our carbonates. This is going to be our iron carbonate, which is siderite. A dead giveaway that this is our iron carbonate is just because the color is so different from what we've seen before with our other carbonates, right? We see kind of that iron oxidation color, that red orangey tinge, a little darker up here where maybe there's more iron. And so this is the first thing that I personally notice when I see siderite. I also notice the lack of really good crystal form, crystal shape, crystal face, anything like that. In a lot of the other samples, we have good preserved faces. This looks more like a massive form, and this is really common. If you were to find siderite in the field, this would be really similar to what you would be able to find. So color, pretty good giveaway. We've got that iron oxidation. Let's give it the rest of those tests. So we're in the carbonate family. Let's see if it reacts with our trusty HCl. I'm going to powderize this and see if we can get a reaction. When you powderize samples, you create more surface area for a reaction to occur. So we'll see if we get anything, but I'm going to tell you right now, having done this a little bit earlier, I did not get a reaction, but we'll see. It's also clearly softer than a nail and a little bit harder than a penny, but we'll see if we can get a reaction. So, no, not really. And the way that I tell is I look at this kind of trail of clear HCl that hasn't reacted with anything. The white that we see there is actually just the stuff that I powdered. So we're not really getting a reaction here. And always pay attention more to a hand sample test than anything that's said in a book, because samples can be impure. So no reaction there, which helps us to distinguish this from other really reactive carbonates like calcite and aragonite. So we did hardness, the luster of this. This one's a little bit earthier, right, because we have that iron oxidation going on, but we do have some nice crystal faces where we can see it's got a vitreous luster, just like the rest of them. It's also moderately low density, a little bit denser. This is probably the most dense out of all of them because remember, we have iron now, so that's going to give us a little bit more heft than the other ones where the cations are not as massive. We also have the cleavage here. We would be looking for rhombohedral cleavage, just like we did in calcite. However, it's just not as readily apparent. Some samples, like this one here, you can kind of see a shape, but it's really difficult to see. So lack of really apparent cleavage would be something that helps me distinguish this from other samples. Let's look at this one. We might be able to get a little better sense of the cleavage. So you can see those cleavage planes right there. Those non-90 degree angles are a dead giveaway. Something else that we haven't talked about yet for the carbonate minerals is that they tend to grow in curved crystal forms, or the crystal faces like to grow in a curved shape. So this one here, we can see with the light reflecting off of it, it's not a completely flat surface. And this is really typical, and we'll see better examples of it in other samples like dolomite, for example. So we did luster. The streak of this would be white, maybe a little tinge of a yellowish color, but certainly not something we'd use as diagnostic. I suppose if you were trying to decide this between something in the oxide or sulfide family, that streak would really help you out, but it should be really fair and light. Let's see, we also have the color, the effervescence, and then these massive forms are really common. So I think we've covered everything for siderite, and we'll move on to the next one.